Okay, so the question is asking about homework assignment number 5. Because homework assignment number 5, I like you to design a bunch of objects to represent the JSON. So let me first just give a little bit background. So okay, what do you want? I need to share my screen first. Wait a minute. Okay. Okay, you can see my screen. So I'm going to my screen document. So I was referring to this picture about, okay, you have a JSON, and how do I represent this JSON into a bunch of C++ object, which means I have to define classes for those. And the question was asked, I mean, how many classes I need to define on the left. So it should really depending on what do you have, what do you need to represent in the JSON. Okay, so I'm going to show you something which is my own implementation, which is just a reference implementation. But this is just a reference, just a guideline, but you are free to do whatever you think is appropriate. All right. So you can see that this is, let me just do this. I actually define 10 different classes in my implementation. This basically follow the JSON that we need to deal with for this case, for both the base JSON as well as the update JSON. We have 3 JSON that we need to handle. So of course, this is from homework assignment number 3. I have a person.h, and because I have a person.h, I also need core.h. Okay, person.h inherit from core. That's why I have a person and core. And then I have what I call the message.h, which represent the core message in the post. Maybe I just show you my post. That might be the easiest one because I already showed this in the lecture. So this is my post. You can see that it include pretty much everything else, including core, tag, comment, reaction, message, person, link, action, and my time. And let's look at what is a post. A post is just this portion of code as I show on the video. And you can see that a post has what we call a profile ID and post ID. I don't need a new class because those ID are just string, just like your VS ID. And I do need to have a person object because every post has to have a author who is writing. So this is equivalent to, let me actually do this part. Let me have another window. Let me create a new shell window. Oh, let's look at our JSON. Okay, let me make this a little bit bigger. you can see what's going on. Okay, so this is a base JSON, and this is the code. So let's see where's a person. The person object is actually here. You have to look at this very carefully. The person is from here, is from. There is a key value pair from avatar name, Oracle VSID, blah, blah, blah. And that's the information is going to come into the person object. And then the next one is, I don't need you anymore. The next one is 2. You can see that this 2 is a whole array because you potentially can have multiple of 2 that you want to send it to. And this 2 is an array. Array has a data and count. And each inside here is also avatar name and VSID. So it's also a person. So that's why I have receiver is a vector of person. It's a vector or pointer to the person object. So that's why now, up to now, when we deal with the from and to, we really need only 2 classes. One is a post and one is the person. And then I have a message. The message object is actually going to be really simple because if you think about what is a message is try to capture this one. Try to capture the string of doing, this is a message. I mean, potentially I can just design message as a string without making another class. That's your choice. The reason I actually define message as a class because later I like to implement a message with tag that somebody actually embedded like a URL or some kind of tag inside a message. So there is for future extensibility, that's why I have that. Okay. And then the next 4 are all vector. Vector of links, vector of action, vector of reaction, vector of comments. By the way, they're really similar, especially between links and action. They're really similar. The structure and the code, that's why I need 4 different classes. One for link, action, reaction, and comment. And if you look at what I have, this is a link. After this is a link. This part is link. It's also an array of URL, class ID, object ID, things like that. Very similar to core object.
Professor,
Yes.
could you explain what the difference is between a vector and an array?
They're the same. Vector and array, they're the same. It just the only difference is that, I mean, array is a C concept. In C++, we use the more, I would say this, when you deal with array, the array, you have to basically, let me actually put it here. So here's a C++ array. For example, you define reaction. Let me just assume reaction is a class you already define. Reaction star, you define AAA, say 200, right? So that's typically an array. So a vector, the way we define is define. Let me actually just pick my own code so I won't mess up. Let me just save AAA like this. By the way, these 2 declarations, they're actually convey the same information. This is an array of 200 variable. This is the array of, I'm sorry, it should be, oh, yeah, okay. There is a big difference here. In vector, I don't need to specify how many I have. In, thank you, I was wrong. It's not entirely the same. Because when you declare array, you have to declare what is how many elements you have in the array. But in a vector, you don't need to do that. And otherwise, you can also use the same way to access say A AA2, AA3, you can use this for vector as well. You can basically say like a AA25. I mean, it's just the same notation for you to access to that. Okay, so in that sense, they're the same. Means that they have the same interface. Once you declare it, you can use this bracket format to access to that. Okay, so now here is a difference that why we need to use vector instead of using array, because they build in a few things which is really nice for you to use the vector. I mean, for example, typically when you have array like a AA, you usually need to have another variable called count, which tell you how many elements that you have that within this array, because this array itself doesn't tell you how many. Even though I declare it's 200, I might really have only 20 elements. So I need to have a count for me to keep tracking how many elements I have in this array. And this is built in by the vector. So vector, you just say a.size. You just call a function called size. It's a member function called size, which basically is associated with every vector. And AA.size basically tell you how many elements you have in the reaction. Okay, so this is similar. That's why let me use an example.
So is vector a class that we're calling, or is it an actual data structure in C++?
It's a template. We haven't talked about template. I was want to wait until the last part. After exception, I'm going to talk about template. And it's a template that C++ has. It's really powerful for us to do very generic thing. That's why you can have a template of vector is a template. It could be vector of integer, vector of a reaction, integer of anything. Vector is a template. Okay, I will cover vector in the future, but right now you can start using vector. In fact, I think is probably good for you to do that. Let me actually see where's my code. I can do that. Oh, I don't have it here. I didn't actually see that. Do I have it here? Do I have this code here? No. Okay, I'm going to show you a piece of code which tell you how I'm using that. I would say it must be in comment CPP. So I'm going to do the dump J for comment. So you see that this piece of code, because a comment has a array of reactions, because each of the comment you could have a reaction. So this piece of code I have for my dump J for the comments class. And so the number one I always check is whether by the way, reaction is a vector. So first I check whether the size is greater than 0. If the size is not greater than 0, there is no element in this array. It means there is no reaction for this comment, no like or no love, hate. So I'm going to skip it. So it's only when I have this size greater than 0, then I'm going through the loop to actually iterate through each of the reaction. So you see what I'm doing is that now I'm set up a for loop. I is equal to 0, I is smaller than this reaction, again, size. So that is my loop control to go through each element of the reaction indexed by I. And then I'm using this just like array. This is array index. That's how I actually use this to do that. And by the way, I have another array called JSON array. Okay, JSON array value is actually being stored there. Then I can also use JSON array I to store the value. So this is how I put each element from the C++ object array of object to JSON array of object. That's how let's show you an example. I did that. Okay, Jason, do you have any Is this okay for you to just get some basic concept about the difference between the array and the vector?
Yeah, so when you declare vector, you don't need to know the size of it, correct?
Exactly.
And you can keep adding to the end of it if you need to?
Right. We
Okay.
use pushback. We use the array has a bunch of functions like a pushback, and you can clean. You can actually just erase everything by declaring cleannet. And so they have a set of function. So yeah, you're
Yeah, so
exactly right.
what I'm understanding is like, I don't know if you're like in Java, but like in Java, there's an array list and it seems very similar to this. And there's like a dot get and a dot remove. Does vectors have all that as well that you can use?
Yeah.
Okay, gotcha.
I think this part of C++, to be honest with you, was heavily influenced by Java. Heavily influenced by Java. Yeah. I think this was first introduced in Java, then C++ world kind of copy it
Okay, thank
into
you.
their design. Yeah, good. Yeah, I'm glad that you can make that correlation. Okay. All right. Any other question?
Are we inheriting from any or any of the classes inheriting from one each other, or we don't?
Andrew, say it again.
Are any of the classes inheriting from one another, or are we not implementing inheritance in this?
Okay. In this
you want
case, in this project, I think there are certain things that can be inheriting from each other. But in my base reference implementation, I didn't use any inheritance. I just only inheritance relationship among my code is between person and core. And because the reason I was not creating that inheritance relationship is just because homework 3 I already have that, so that's why I keep it there. But you don't need to have inheritance in this case.
Okay, thank you. Just making sure.
Yeah. But potentially in the later homework, you can optimize the code because you see there's a lot of similarity. You can use inheritance, you can use template. I tend to let you use template for the last homework assignment because template is a very useful, very nice concept, just like the standard vector template. But it could be tricky because you essentially define something very generic. It's similar like inheritance. You try to generalize something so you can reuse the code. Yeah.
Okay, I see. Thank you very much.
Thank you. Okay, any question? Let me check. Let me first stop my recording and then I can check the